Hello everyone, this is Balu. Welcome to my channel Civil Cave. In this video, I am going to discuss about one of the most important topic, that is why we are using different types of cross sections in the steel industry. Why not a unique shape? Here you can see these are the different cross sections, that is wide flange I section, normal I section, channel section, angle section, T section, also circular hollow section, square hollow section, and solid rectangular section, solid circular section, and also plates. Few people simply say that based on the applications and also based on the situations in the civil engineering industry, we are going to use different types of cross sections. And also few people also comment that I section is a universal section and it is having high load carrying capacity, so we prefer I section. Now, what are those situations and what are those applications and how you are judging that I section is a universal section and how it is having the high load carrying capacity? These are all the possible questions in which you will be able to answer. You are an engineer and also you will be able to answer why we are using this particular type of cross section. And also you will be able to explain in engineering terms. Then only you are called as a real engineer. At the end of the video, you will be able to answer to all those types of questions. So please watch the video till the end. And also if you have not yet subscribed my channel, please subscribe my channel. And also if you like my content, please like the video. For example, if you consider any structure, it may be building or it may be any other structure. These are the possible types of loads which is going to act on the structure. That may be point load, UDL, movement, or any rotation or torsion you can say. Because of the action of these particular types of loads, there is a generation of a structural phenomena that may be compression, tension, shear, flexure, but maybe torsion also. Now, you are a designer. You have to design a cross section in which it will be able to carry the load within the possible area only. Now, what are the parameters which will be going to play an important role in the cross section is? Those are area, depth, thickness of flanges or webs. Based on the variation of these three parameters, you are going to get moment of inertia and also torsional constant. Now, you are a designer. What is the responsibility of you? And you should be able to come up with a solution in which it is having least area, depth, and also least thickness of the flanges and also webs. For example, in your structure, particular structural element is undergoing more shear and also flexure. In that case, you can prefer I section. And another structural element is having high torsion, but whatever the other things that may be shear, flexure, tension, all these things are very minor. In that case, you can prefer hollow sections. In this way, each and every section is having particular importance. And also if you consider channel section, it is having mild flexural strength and also high shear strength. In this way, each and every cross section is used for particular different situations. So, based on the each and every cross section application, you can prefer different cross sections at different situations. Absolutely, you have to find a cross section in which it is having high material to capacity ratio. Within the least possible area of that cross section, you have to come with the higher capacity value of that cross section. These are the different types of cross sections which are used in the steel construction. Here you can see this is the I section. I section is having the capacity to bear whatever the flexure, shear, and also axial compression capacity. Now coming to the torsion, it is not having the torsional resistance capacity. It is not at all preferred in case of torsion load. Next, coming to the channel, if you observe carefully, in I section, if you just remove this flange part in the top and also in the bottom, you are going to get this channel section. Now that means whatever the flanges in the I section, these are going to resist the flexure coming onto the structural element. So here you are reducing the flange part. So that means whenever the intensity of this flexure is low, you can prefer this channel section. Next, coming to the angle section, these are preferred in case of whatever the connections. If you watch whatever my previous video, in that seated angle connection, web angle connection, and all other different connections, this whatever the angle sections are used. Next, coming to the T section, it is just similar to the whatever the I section, but whatever the flexure which is coming onto this section, in the top flange part, it is going to be resisted. In the bottom, there is no flange at all. So there is no flexural capacity in the bottom portion. Next, coming to the hollow sections. These hollow sections are particularly preferred in case of torsion. There is a reason behind whatever the usage of these sections in the case of torsion. That reason I am going to discuss in the upcoming videos. So please stay tuned for the upcoming videos also. Next, coming to the whatever the solid sections. These are used in case of very high loads which is coming on to the structural element. Now this is a plate section. These plate sections are used in making the built-up sections. It may be plate girders, box girders, and all other different types of sections. So this is just a glance on these all different types of cross sections used in the steel industry. So if you like my video, please like the video and also subscribe my channel so that you never miss the updates regarding my channel. Thank you for watching. See you. Bye bye.